In Module 11, we're going to talk about 3D figures. And in Section 1, we're specifically going to talk about prisms. So before we start off, we have to define a polyhedron. And a polyhedron is a solid with flat faces that are polygons. So a solid just means three-dimensional shape, and most of the three-dimensional shapes we talk about will be polyhedrons except for a couple. So the first polyhedron we're going to talk about is a prism. And a prism is a solid with two identical bases and flat sides. And these two identical bases are going to be polygons of some sort. So a few examples. So this first prism we have, its bases are rectangles. So it is a rectangular prism. Our next shape has two triangle bases. So it's a triangular prism. Next, we have a solid with pentagonal bases, so it's a pentagonal prism. And then lastly, our bases are hexagons, so we have a hexagonal prism. So as you can tell, the way we name a prism is based on whatever those bases are. Whatever the shape is, that's what defines our prism. So now let's get into finding some area. So we're going to start with base area. And base area is the area of the identical bases. And there are, in this case, two bases in every prism. So we're going to find the base area of each of our prisms. So the first one we have is a rectangular prism. So when we're trying to figure out which rectangle is our base, because all of the faces of a prism are rectangles, we're going to look for the ones that are kind of shaded to help us figure out which one are the bases. So our shaded rectangular base is this rectangle right here. It has a length of 8 and a width of 4, because we also know its other base is parallel to that. It's an 8 by 4. So the way we find an area of a rectangle is length times width, which in this case is going to be 8 times 4, which gives us 32 meters squared. But that's just the area of one of our bases, and there are two of them. So we have to do 2 times 32. So we get the area of our bases is 64 meters squared. And because this is area, our units are square units. Next, we want to find the base area of our triangular prism. And it's important here to indicate this is a regular triangular prism. And what that means is that our base triangles are equilateral triangles. All of their sides have the same length. So in this case, our triangle has 3 sides with lengths of 10 meters. So when we go to find the area of a triangle, it's 1/2 base times height. But we don't have the height of our triangle. We just have the base. So what we need to do is find it. So when we find the height of our triangle, because it's an equilateral triangle, when we draw our height, which is our perpendicular distance, it's going to split the base in half, which means this distance is 5. We also know that because it's an equilateral triangle, the hypotenuse created by that triangle also has a length of 10. So in order to find our height, we have to use the Pythagorean theorem. So using our Pythagorean theorem, we have that the height squared plus 5 squared has to equal 10 squared. So we get h squared plus 25 equals 100. When you subtract 25, you get that h squared equals 75, and when we take the square root, we get that the height is 5 square root 3. we now have enough information to find the area of one of our bases. So the area is going to be 1/2 times our base 10 times our height 5 square root 3. So when we do 1/2 times 10 times 5, we get 25, and then our square root 3, and then the units are meters squared. But because, again, we have two triangular bases, we have to multiply this by 2. So we do 2 times 25 square root 3, and we get 50 square root 3 meters squared. Now, it's going to be nice to have an approximation of what that number actually is. So 50 square root 3 is 86.60 as a decimal. So the area of our triangular bases is about 86.6 meters squared. Our last example is a regular hexagonal prism. So just like with the regular triangular prism, means all 6 sides of our hexagon are the same length, which means they're all 4 feet. Now, there's no exact way to find the area of a hexagon, but what we can do is we can split that hexagon into 6 equilateral triangles. So the way we find the area of a hexagon is 6 times 1/2 base height, because there are 6 triangles that have the same area of 1/2 base times height. So now we have to find the height of just one of those triangles. So again, all of our triangles that have been created are equilateral, which means each side has a length of 4, and then when I draw the height, I'm going to end up with creating a side with length 2. So the height squared plus 2 squared has to equal 4 squared. So the height squared plus 4 equals 16. So when we subtract 4, we get that the height squared equals 12. So when we take the square root, we get that our height is 2 square root 3. So now when we go to find the area, we have 6 times 1/2 times our base 4 times our height 2 square root 3. So when I do 6 times 1/2 times 4 times 2, we're going to end up with 24 square root 3, and then our units here are going to be feet squared. But we have 2 hexagonal bases, so we have to do 2 times 24 square root 3. So we have an area of 48 square root 3 feet squared. But similar to our triangular prism, we want to know what this is roughly as a decimal. So this is approximately 83.14 feet squared. Next, we have what are called the lateral faces. And lateral faces are the non-base faces, which in this case are all rectangles when it comes to a prism. So the way we find the lateral area is to find the area of all of the faces except the bases. Now we know that the area, because they're all rectangles, that area is going to be length times width, but it's going to be multiplied by how many faces we have. And the number of faces is based on whatever the whatever the base is, whether it's a rectangle, a triangle, or a hexagon. The number of the base shape determines the number of faces that we're going to have. So when we're finding the lateral area of each of our prisms, first we're going to start with that rectangular prism. So we have 4 faces. They're all rectangles. Now, because our base is also a rectangle, we don't actually end up with 4 identical faces. We have 2 rectangular faces that are 8 by 5s, and we have 2 rectangular faces that have lengths of 5 by 4. So when we go to find the area, we have 2 that when we have to do the 8 times 5, and we have 2 that we have to do 5 times 4 to find the area of. So 8 times 5 is going to be 40, so we have 2 times 40 plus 2 times 20. 2 times 40 is 80, 2 times 20 is 40. So the area, our lateral area, is going to be 120 meters squared because this is still area, so we have square units. When it comes to our triangular prism, we have 3 rectangular faces, all with the same area, that has a base of 10 and a height of 50. So our area, we have 3 of them. We have to do 10 times 50. So 10 times 50 is 500, which we then multiply by 3. So our area of our lateral faces is 1,500 meters squared. Lastly, we have our hexagon. So we have, again, rectangular faces. There are 6 of them because a hexagon has 6 sides. The length is 4. The width is 12. So we have 6 times 4 times 12. 4 times 12 is 48. So we have 6 times 48. So the lateral area of our hexagonal prism is 288 feet squared. Lastly, we're going to talk about total area, which is also known as surface area. It's the sum of the base area and lateral area. So it's taking all of those faces of our solid and adding their areas together, and we get the total surface area, the outside of our shape, or our solid. So we're going to find the total area of each of our prisms. So when we start off with our rectangular prism, its surface area, which we abbreviate SA, is going to be its base area, which we found to be 64 meters squared, plus its lateral area, which we found to be 120 meters squared. So our total surface area is going to be 184 meters squared. For our triangular prism, its base area was about 86.6 meters squared, plus its lateral area, which was 1,500 meters squared. So that gives us a total surface area of 1,586.6 meters squared. So this is one of the reasons why we found that approximate area, because in order to find the total area, we were going to need to have that decimal. And then for our hexagonal prism, its total surface area, its base area was 83.14, plus its lateral area, which was 288. So it gives us a total surface area of 371.14 feet squared. So there's no exact formula to find total area, base area, or lateral area of a rectangular prism, because each base shape can be a different polygon and its area is different for whatever polygon you have. So we don't have one general formula we can use to say this is how you find the base area, lateral area, or surface area of any prism. We generalize it. It's based individually on each type of prism you have. But the general idea is the same for each of them. Lastly, we have to talk about volume. So when we find the volume of a solid, we are finding the inside area pretty much. So we need to know the altitude or the height of that prism. So the altitude of a prism is the perpendicular distance between the two bases. And for our purposes, all the prisms we're going to be studying are right prisms, which means that the height is always going to go straight up and down. All of our faces are going to be rectangles, so that the heights we have are all perpendicular. So in this case, all of these angles formed are going to be right angles no matter how we lay our prism. So the way we find the volume of a right prism is by the formula V equals BH, where B is the base area. And this is going to be the base area of one base. It is not both bases. Like when we found our base area, we found the area of both of our bases. For volume, we only find the area of one base because we don't want to count it twice. So let's go back to our original three prisms. So our first is our rectangular prism. So to find the volume, we find the area of our base and multiply it by height, where our base was our 8x4 rectangle, and then our height is the 5 meters. So the 8x4 gave us the 32, and then we want to multiply it by our height, which is 5. And when we do 32 times 5, we're going to end up with 1600. Now the units for volume, because we multiplied 3 lengths that had units, volume is cubic units. So it's going to be 1600 meters cubed for our volume. I actually have one too many zeros here. It's actually 160 meters cubed. So 32 times 5, 160 meters cubed. Next we have our triangular prism. So the volume is the base area times the height. And when the area of one of our triangular bases was the 25 square root 3 times our height, so our base triangle times our height, which is the 50. So when we do 25 times 50, we end up with 1,250 square root 3, and then our units are going to be meters cubed. But again, we want to have an approximation, a decimal for this. So we get approximately 2,165.06 meters cubed for our volume. Lastly, we have our hexagonal prism. So volume is the area of one base times the height. So the area of one of our bases was 24 square root 3. We have our hexagon. And then our height is 12. So when we do 24 times 12, we get 288 square root 3 for our volume, and then our units, feet cubed. So when we find the approximate decimal, we get the volume is 498.83 feet cubed. So let's combine this all and do one last example. We're going to find the base area, lateral area, total area, and volume for our regular triangle prism. So let's start with the base area. So this base is a triangle, so its area is 1/2 base times height. And because it is an equilateral triangle, in order to find its height, we know when we draw the perpendicular height, it splits that base in half. So we're going to use the Pythagorean theorem, h squared plus 3 squared equals 6 squared. So we get h squared plus 9 equals 36. When we subtract 9, we end up with that h squared equals 27. So our height, when we take the square root, is 3 square root 3. So we have 1/2 times our base 6 times our height 3 square root 3. So 1/2 times 6 times 3 is 9. So we get 9 square root 3 and then centimeters squared. But we have two bases, so we have to do 2 times 9 square root 3, which gives us 18 square root 3 centimeters squared, which is approximately 31.18 centimeters squared. Next, we want to find the lateral area. So because it's a triangular prism, we have 3 rectangular faces with its length and width. So the length of our rectangle is 10, its width is 6, so we have 3 times 10 times 6. 10 times 6 is 60, so we have 3 times 60, which gives us an area of 180 centimeters squared. Now let's find the total area. So our surface area, which is the base area, 18 square root 3, plus our lateral area, 180. We're going to use our decimal for the 18 square root 3, so we have 31.18 plus 180. So our total surface area is going to be 211.18 centimeters squared. Last, we want to find the volume. So our volume is the base area times the height. One of our bases had an area of 9 square root 3 times our perpendicular height, which is our 10. So that gives us a volume of 90 square root 3 centimeters cubed. But we want to approximate that, which gives us 155.88 centimeters cubed for our total volume. So let me know if you have any questions when you're working on the assignment over prisms.